Welcome to this AWS Discovery Day webinar. Today's topic will be data analytics fundamentals. Let's get started. So, data analytics fundamentals. This is going to be a high level overview and introduction to data analytics. And we will be exploring some of the sort of core concepts revolving around data analytics and also exploring some useful AWS services that we could use for the data analytics. We'll start with some definitions. So first, let's compare data analysis versus data analytics. So the data analysis is as stated here, the examination of something to kind of understand it, to get more understanding of a particular topic or some data of some type. Whereas the analytics is more of the specific process or systems that we utilize to generate information from the data itself. So more of the uh, process, the systematic process that we use to actually perform the analysis of the data. And the result then is the analytics information that we can utilize, as we'll see in various ways here as we get further into the presentation. So what are some of the benefits of the data analytics? Look at data analytics and dealing with first, as we will get into a little more coming up in the subsequent slides, that we have these days, especially, just a growing and ever growing source of data that's being generated. You have large amounts of data that needs to be stored and handled and processed. And the problem isn't, finding the data or getting the data. There's just many different sources, as we'll explore some of those a little later in the presentation. But the problem is, what can we do with that data? Can we get any useful information? Having a data just sitting in storage doesn't help us unless we can extract some useful information that would benefit our organization, or benefit the customer, benefit our company. So we have to put the data to use. And some of the things that we can utilize and perform analytics on with our data will allow us to provide more personalization for our customers, such as suggested products, perhaps. We can utilize data to detect fraud detection, especially in the financial industry, analyzing patterns of transactions in a banking system, for example. It can be used for security threat detection, whether that would involve human security threats, as we're analyzing data that's coming from a video feed. But that could also include cybersecurity threats, analyzing your traffic patterns and behaviors on a website or web application. Other user behavior, especially with social media, user behavior in social media and interactions. Data analytics can be used to glean information in that realm. We can financial modeling and forecasting, real-time alerting. We're analyzing data in real time and generating some alerts or notifications to take action. Allowing someone to take action on that. So we look at data analytics. There are really four general types with data analytics, and we'll go through each of these a little more in the subsequent slides. But first, the overview: the four different types of data analytics we're dealing with. Descriptive, which is describing what happened. Then there's diagnostic analytics, which is the reason behind something that happened. Why did this happen? Then there are predictive analytics, which is forecasting or looking into the future, based on what has happened in the past. What what may be likely to happen in the future. And then that's predictive analytics, and then prescriptive analytics, which is a guide for action. What should we do next based on what has happened in the past or based on what a prediction might be? So let's see a little more about these. So get into descriptive analytics. Descriptive analytics is a very, very common form. This is sometimes called the most basic form of data analysis because it's just looking at trends. It's describing what is happening as far as a interaction with our web application or our website, interaction with our social media posts, or something along those lines. So we're looking at data, current data, historical data, just to identify trends, in behavior. Something that most organizations use on a daily basis. Examples might be things like traffic and engagement reports, social media analytics, web traffic for our website. Could be financial statement analysis. Also, it could be looking at trends in demand. For example, if you were a streaming platform like Netflix, for example, perhaps you've encountered this, you've seen this if you utilize the Netflix service, that the Netflix gathers a lot of data and then analyzes that data to track the user's use of the platform and what TV series or movies, what's trending, what's common, what's popular. You've seen probably rankings of this movie's in number 7 of the top 10 this week or something along those lines. Then there are diagnostic analytics. Diagnostic analytics was looking at the reasons behind the trends. Why did the trends occur? What are there correlations and causation that we can determine based on the information we have? So we're looking at the diagnostic analytics to just determine the reasons why we're seeing the trends we are seeing. If we could determine that and pin that down. So this could be used to explain customer behavior, for collecting data about the customer, give us information about why we're seeing the trends we are. It could be used to identify technology issues. So diagnostics can be run on systems, our computer systems, software. We run some tests to determine that there's some issue that maybe we could identify. And of course, we're looking for the reason and the reason possibly cause for that behavior. Then there's predictive analytics. So predictive analytics is predicting or forecasting based on current and historical trends and data what is likely to happen in the future. So common forms of this that we're all familiar with be things like the weather forecast, for example. So this is dealing with really trying to predict the future to allow us to anticipate, right, what coming around the bend. So other examples, in addition to the weather forecasting, there can be predictions in entertainment or hospitality industries, for example, like hotel operators. You're predicting, well, based on our historical data. We do use predictive analytics to determine what sort of staffing do we need based on specific times of the year, specific days of the month. Similar thing done by restaurants, looking at the busy times of the week and how many servers should we have, how many cooks should we have in the kitchen. Manufacturing also use predictive analytics, manufacturing and industrial processes. In that realm, predictive analytics we use to take action based on the historical information with our hardware devices, for example, or machinery, possibly preventing malfunction, but to some extent being able to predict that when a machine is likely to fail based on observed behavior. Then the fourth type of data analytics was the prescriptive data analytics, which is all about action. Here, prescriptive analytics, there we're dealing with action. What should be our next steps based on the trends we are seeing and the causes we're able to determine, and what do we predict to happen in the future, and then what should we do about that? And this is a guide for making decisions on, of course, how we move forward. But always we should remember, prescriptive analytics often uses machine learning algorithms to process the data, because machine learning algorithms excel at processing really large amounts of data. It's not really possible for humans to process the amounts of data we're talking about here. But humans should always be involved, right? The human judgment, very valuable and necessary part of the whole process. Don't leave machine learning algorithms to on their own and just take their recommendations at face value. Should always have the human element involved in making the final decisions. We don't want to blindly rely on output from a machine learning algorithm. So some challenges we have to deal with in data analytics. One, a business challenge. So you've got a company maybe is growing very quickly. The amount of data they're collecting is growing, and they want to gain some useful insights from that data that they are collecting. So we have our representative of our company here. I've got 800 terabytes of data, and I need real-time insights. So we have large amounts of data we've collected. I want to get near real-time insights, not as little lag as possible between collecting the data and actually extracting some useful information from it. So we need a solution. We need a data analytics solution. So we're going to get into these what's called the five V's when we're working with data and data analytics. Five V's, two of which show up here: the volume and the velocity of the data. Only two factors that come into play when we're looking at implementing some type of solution for my data analytics. So let's look at the challenges and what the customers are wanting to get out of their data. Then we'll get into those five V's of data analytics. So customers, of course, want to get value from the data, be able to put that to use it to benefit their organizations and companies. The data is growing, data storage growing exponentially as we collected data from a variety of sources, many different types of sources that we may collect data from, coming from social media feeds, your web application clicks, video, audio, other devices, what we call the Internet of Things, IoT devices like sensors and thermostats, etc. Wide variety of data in different formats. We could have many people from different teams and departments that want to be able to use this data in the organization for their own purposes, and many different applications maybe being applied to the data to analyze it. So we need to support for all of these things in order to extract value from the data. So the challenges include the five V's here. Let's see an overview of these, and then there's more details following. So the five V's. First V we'll look at here is volume. What's the amount of data that we're collecting, right? Which is in a lot of cases, especially for large multinational companies, be very large amounts of data. Then second V is the velocity, speed at which the data is generated, or the speed at which it needs to be processed if we wanted to get real time or near real time results from the data. Then there's the variety of the data, different types of data coming from many different sources that needs to be managed and stored and processed. Then we worry about Data veracity. Data veracity is the data true? Is it accurate? Is it reliable? Has the data been modified or falsified in some way? Has someone tampered with the data and changed it perhaps? So we don't have a true representation of the actual data we collected originally. Then the fifth V would be the value, actually extracting useful information or the meaningful insights, from the data. So let's look at each of these. Look at volume. The volume of the data is dealing with now data storage. Large amounts of data being stored, it's constantly growing. So we need some sort of scalable storage platform that will allow us to add more capacity as necessary to store the data if we continue collecting that. Data is coming from many different sources, from again the Internet of Things types of devices. Think about some you may have in your office or even at home. Your smart thermostats, like a Nest thermostat, for example, smart lighting systems, voice controlled digital assistants like the Amazon Echo devices you may have at home or in the office, possibly. Um, data from fitness trackers, a Fitbit or an Apple Watch, collecting health metrics and data about you, and cars, modern vehicles these days, a number of different sensors collecting information about the performance of the system, various systems, the fuel efficiency, your driving patterns. Another area of Internet of Things includes agricultural realm, where sensors are used to monitor things like soil moisture and crop health and weather conditions and water levels, so we can take some action, based on the data that's being collected. So, as well as other digital forms of data, whether it's financial transactions, social media interactions, or any other devices might be applicable to your area of business. So volume can be a problem if you're collecting all this data, but you don't process it or analyze it or put it to use. Well, then what's the point? You're spending money, storing all of it, but you're not actually processing and utilizing it. Then you have a problem with the volume of data you're collecting. Now, with regards to AWS services that could be useful where you deal with the volume of data, we will see there's one service that comes up repeatedly. It's going to come up later in the presentation here too. That would be S3. This is really our sort of core solution for storing large amounts of data. Highly scalable solution. You could store a virtually unlimited amount of data in the S3 service on AWS. And then we can use many different tools, like we'll see some examples a little later in this presentation, many different tools to analyze the data, extract your information from it. Other services that might be relevant on AWS, Redshift. Redshift is a data warehouse. We're going to talk more about data warehouses later, near the end of the presentation. But data warehouse, we're allowing us to perform your large scale data analytics, capable of processing petabytes of data. And then later, also, we will discuss more about lake formation, another service. This this is data lakes. So we'll look at and define, what's a data warehouse versus what is a data lake, and we'll define those things a little bit later. But data lake formation, that service allows us to store large amounts of data and use tools to analyze it, to extract useful information from it. Then our second V, velocity, the speed at which the data is generated, also the speed at which the data needs to be processed. The data needs to be processed at or near real time. That needs sort of specialized services and technology and expertise to be able to do that. And just dealing with the velocity of data that's coming at us, especially if we have to deal with data that's real time streams, like it might be from video or might be from uh, financial transactions in a worldwide banking institution where there's just hundreds or thousands of transactions happening around the world, every minute. So it can be a struggle to deal with that velocity, struggle to get any useful information or get rapid insights data like we might need to do with a financial institution to rapidly detect in real time that there's some fraudulent transactions that are currently happening so we can stop that as soon as possible. So you need that sort of near real time results and insight into the data, but the systems we are utilizing can't really give us real time type of results. Well, then there's a problem with the velocity. You're not really getting the value from the data that we're collecting. Comes to processing data, there are kind of two basic ways that data could be processed. And those would be, well, it could be batch processing or or stream data processing. So if you compare those two, look at batch processing compared to stream. With batch processing, what are we processing? Well, we're processing a data in some data set. We process applying queries or processing over all or most of the data in a data set. Compared with stream processing, we're just processing what's happening at the moment. Maybe there's some sort of time window we're working with, or it's just the most recent information. So what's happening now, and then what has happened maybe in the last 5, 10 seconds, whatever our time window might be. Batch processing also be, well, what's the data size that we're processing? Could be large amounts of data, large amounts of files that are being processed. Versus stream processing, usually smaller pieces of data, but very, very frequently, and that's possibly changing frequently as we're looking at data in a stream of data in real time. Then there's the latency with batch processing, maybe something that we maybe collect large amounts of data, and then we run a batch process on that data at some point. So just depending on the interval, what you desire, could be minutes, hours, longer, perhaps could be days. Maybe you do batch processing once a month or something like that. So there's a lot more delay, there's more latency. And with the stream data processing, we're talking about near real time. So delay could be seconds or milliseconds, depending on how we're processing it. And the analysis, what are we actually gathering from the data? In batch processing, since we're not really pressed for time, we could have more complex processes taking longer periods of time, allowing us to get more complex analytics from the data. Stream processing, I really can't get too complex or in depth when we're trying to do something in real time. So we get a basic overview typically, aggregates of data or data points, real time metrics that are changing. No really complex in depth analytics there. And what about services? So AWS services that could be useful dealing with the velocity problem include, among other things, the service called Kinesis. Kinesis, which allows us to deal with real time data streaming, processing it, collecting it, analyzing it in real time. There's different features in Kinesis, and we call it Kinesis, streams and Kinesis data fire hose and so on. Then there is MSK, which is managed streaming. So from AWS, Amazon, managed streaming for Apache Kafka service, which is a fully managed, highly available implementation of the Apache Kafka uh, service. which is used for again analyzing streaming streaming data. Then there is EMR, Elastic Map Reduce, which is in uh, Amazon support for various open source frameworks such as Apache Spark or Hive or Presto, which is used for analyzing data. Some of them using machine learning capabilities to analyze large amounts of data, petabyte scale data processing. And then there is AWS Lambda. Lambda can be useful for responding to real-time events. Lambda is a primarily an event-driven type of code where you can create some code or some small application, which is then triggered by some event that occurs, like some event we see in some streaming data we're analyzing, or some metric that has been increasing or been incrementing based on what we gathered from our real-time data. And the metric exceeds a certain threshold that could trigger Lambda function. We could take some action, have that code running inside of that Lambda function do something for us. Then the next V, the variety of data. Variety of data. We're going to talk about three different types of data we'll see come up in a few of the slides here. That is structured data, semi-structured data, and then unstructured data. And we'll define more about what does that mean exactly. So we have a wide variety of data coming from many different sources. That's a challenge because we're just overwhelmed by the just number of sources that we need to collect data from, which could be, systems, computing systems on our network, could be the devices in a manufacturing environment. It could be like we've discussed uh, web clicks and social media analytics and interaction, advertising interactions, interactions with ads you're running online, as well as a variety of other sources. You might have your own, custom sources too that are all generating data that we need to deal with in one form or another. So we look at data structure and types. Let's define first the structured data. Structured data we're working with. That's this section here. Structured data. This would take the form of a highly organized, searchable format where there's some specific format that the data has been placed into. And best example of this would be our typical type of databases that we may work with in organizations. The SQL type databases, which we can query with the structured query language, right? SQL, also known as relational databases. That's structured data, usually in a table format. There's multiple tables that may, reference each other, and all usually in the context of the database management system and a DBMS. Then we may have to deal with structured data or semi-structured data. Semi-structured, so that's the middle section here. Semi-structured data, which is data that's not as tightly defined in the whole table and rows and columns type of format that we would have with a SQL type database. There's still some predefined structure, perhaps, but there's a lot of variation. Some examples would be JavaScript object notation data, JSON format, XML data. A lot of your applications will exchange information in JSON or XML between client and server. CSV formatted data, so comma separated value data. There are databases examples on AWS and others, like DynamoDB database, which it's not an SQL, it's not a SQL type database, it's not a relational database. It's really more of a key value pair. And the value could be in different the value, the data of a particular entry, and it could be in various formats. It could be in JSON, it could be string, string type of data, could be an integer, could be binary, many different variations there. And other examples. So that's semi-structured type of data. Then you have unstructured data, the last section here. Unstructured data, which is usually the form of just various types of files. Be text documents, could be audio files, images, video, other documents, emails, PDF files, Word documents, etc. Where there's no real structure, right? There's some organization, of course, inside of files like a text file or emails, but there's no predefined structure. You never know what you're going to find when you open up first one of these files. So that's the challenge with the data variety, dealing with all those different types of data. So what do we have in the way of AWS services for dealing with the different types of data? Well, for the structured data, relational database, SQL type of databases, those can be run and hosted with a service called RDS, the Relational Database Service. Supports a variety of database engines like Oracle and Microsoft SQL Server and MySQL and Postgre and so on for those highly structured type of relational databases. Then there's DynamoDB, as I was describing, this is what's known as a NoSQL database. Does not have a tightly defined schema, means that there's no tightly defined format of how the data or what type of data it might be. Stores data primarily like a key value pair type of association. Then we have Redshift. The Redshift service from AWS is a data warehouse service, which can be used for processing, again, performing data analytics on petabytes of data at a time. And then there's the OpenSearch service from AWS. OpenSearch, which is search and analytics engine for a wide variety of data types. So you can search and analyze different types of data. Then our next V, the fourth V would be veracity. Looking at veracity, this is asking the question of how accurate is our data? What is the quality of our data? Is our data true? Is it reliable? Is it trustworthy? Because this really comes down to the old familiar saying of garbage in, garbage out. Right? If we have low quality, untrustworthy data, and we use that and perform analytics on that, well, we're going to get bad results. Going to get bad, predictions based on that data, which could lead to taking improper action as we, move forward. So we really need to know what is the quality of our data. Is it reliable? What about inconsistency in the data, noises, missing information, duplicate data? How can we maintain the data integrity? Make sure the data is not modified in some way. The data isn't intentionally tampered with or intentionally falsified for some reason. So that can be the challenge when you've got data you're collecting from numerous systems and departments and teams and divisions in your company. And you need to really maintain the data, as they say. You need to curate the data, manage it in useful ways. Otherwise, you can't really the trust the data. So this is really asking the question: how confident are we that the data we have is right, correct, true? Data integrity part of that. We expand on looking at the data integrity. We're looking for one, accuracy. Data integrity guarantees that correctness, the consistency, of the data. There's data security. Security side, make sure the data is maybe kept private if it's private data, especially if it's customer information, right, we're using to perform analytics, or private data for any other, private data for our company, and that we prevent unauthorized access or manipulation to maintain its integrity, to make sure we don't have unauthorized access in some way that would modify the data, which of course would affect the results we gain from our analytics. And another part of the data integrity, reliability. Make sure the data is highly reliable. We can trust it. We can depend on it to be true and accurate, and an accurate representation of the actual events that happened and the data we're collecting. That they reflect the actual events or behaviors that we were tracking. What about AWS services? We're dealing with the variety of services available. There's a service called Glue, AWS Glue, a fully managed ETL service. That's going to come up again here in a minute too, but fully managed ETL service, extract, transform, and load service. Meaning it's that part of what we're doing is cleansing the information or transforming it. Glue will do things like removing duplicates. We detect and manage duplicate entries and remove those. It can detect missing and null values, useful for filling in the gaps for incomplete records. Data normalization, make sure we have consistent formats of data, like dates, date formatting, for example, because that can vary. Then another service, EMR. EMR, Elastic Map Reduce, which is like we saw this come up on the previous slide. Also, is used for running the performing and running analytics with machine learning open source frameworks. And these would include Apache Spark, Apache Hive, Presto, which are some common frameworks used for analyzing data. EMR provides a environment for running those on AWS. Then there's Amazon Data Zone. Data Zone is a kind of central hub for managing all your organization's data. So you can catalog, discover, govern, share the data. Challenge with a large organization is that we end up with data silos. Each department, division, team has their own database, and all the data is separate. There's no coherent view of all the data that's being collected across your entire organization. Data Zone can help work around that problem. And then there's Glue Data Brew service from AWS, which is a visual data preparation tool. You can clean and normalize data without writing any code. You can choose from over 250. Data Brew provides over 250 pre-built transformations. So you can utilize those to prepare the data, filter out anomalies, convert data to standard formats, and many other type features. Then there's value. So this is the fifth V. Value involves dealing with the data. So once we've collected all of our data, we ensure that we ensure its veracity, right? Its truthfulness. Then the raw data, of course, that doesn't help us at all. Just the raw data itself. It's just sitting there. We don't actually process it in any way, getting any meaningful information from it. Well, we need value. To extract value from the data means, well, we need to run some sort of analytic process, some analysis on that data to get usable and meaningful information from it that we could use to take action. So value just referring to, what do I do with all this data I collected? We can use that to gain some insights. And there are you can break it down to like two different categories. What's often referred to as golden insights, which are highly valuable findings that we've been able to extract from our data. Often the main drivers of strategic decisions that a company will make, as they move forward and where we're going to invest and invest in our advancing our company or what region of the world and so on are going to be working in. But if those golden insights were derived from just a small portion of the entire data set, well, then we could be missing other important things too. So if we're not fully utilizing the entire data set, then we could be missing opportunities. We're missing other important insights. I'm sure we got a few things out of it, but it could have been much more useful. Could have been much more beneficial for us if we were able to examine all of the data instead of only examining a portion of it. So services that will help us extract value from our data. QuickSight service. QuickSight service is a BI, okay, it's cloud-powered business intelligence service, provides interactive visualizations and insights to guide decision making. Then there's SageMaker, SageMaker service from AWS. This is a service for machine learning and AI. You can train your own machine learning models, use machine learning models, train your own AI with this. So you can develop, train machine learning models that you could apply to your own data. Those models, of course, can be used to extract useful or valuable information from your data. Then there's the service called Athena. This is a query service, allowing you to perform SQL type queries on a variety of data sources. So we talked about S3 a few minutes ago. We can store large amounts of data, petabytes or exabytes of data in S3. One of the ways I could extract some information from the data stored in S3 is using the Athena service. Allows me to query the contents in S3. But Athena will also work with other services too for querying your data. So there's a summary of the 5 V's that comprise the challenges for organizations dealing with data. We have the volume of data. We need safe, secure, scalable storage solution to store the large volumes of data. And our primary solution there would be services like S3, for example, storing a large amounts of data. Then there's the velocity of data, as we're processing data at or near real time, accepting input in the form of streaming data, but then I'll also have to process and get results from it in near real time. There's a variety of data, the data structure, the structured data, unstructured data, semi-structured data, variety of tools and services from AWS to deal with those things. And then there's veracity of the data, means the cleansing and transformation of the data, making sure the data is accurate, that it's been normalized and cleaned, duplicates removed, and missing data identified, null values identified. And then finally, the value of the data, driving useful or beneficial insights from our data. So overall, components of a data analysis solution that could look like this, what we're seeing here. So we will one first step. First step is the ingestion and collection first of the data. Ingesting data from a variety of sources, like we discussed, and it's going to be in different formats: structured, semi-structured, unstructured data, as we had discussed. That data needs to be stored somewhere so we can gain access to that. The storage has to be reliable and secure, be able to lock down exactly who has access to that data so we can make sure we don't have unauthorized personnel or systems accessing the data, and possibly leading it to be corrupted. Then we're going to process and analyze the data, make the data, consumable. Maybe get into a format, especially if you're dealing with raw data that came from a variety of sources, not really digestible in its raw format many times. So we have to process it and get it in something that can be more easily consumed. Then visualizing, and of that visualizing the results after we process and analyze the data, we can then look at the information we were able to gather from the data, the insights we can use for in making future decisions for our organization. So ingest and collect, store the data, process and analyze, and then use the results of the analysis, consume and visualize those results. So one of the solutions to working with the data, we're going to compare, really look at and compare two things here. We'll first start with the data lake. Data lake is a decentralized repository that we store really any type of data. Data lake is built and able to store our structured, semi-structured, unstructured data at any scale. And then when we look at the data lake, and really we're talking about the S3 service here. So you have your data store where we just can put all the raw data here. And then we can use a variety of tools and apply that to the data stored in the data lake. Machine learning tools, be other analytics tools like we were seeing, Athena to do querying on the contents of S3 storage, data coming from a variety of sources. We can data migrated from on premises, for example. If you have multiple divisions or departments, that we had that problem with the data silos where every department's got its own database. Everything's separate. Well, that can all be uploaded or migrated or at least copied periodically to the data lake storage, and then we can perform analysis on that. So this is useful to have a sort of single source of truth, where all the data stored in one place, any type of data, regardless of structure. But then that's just the storage, but of course we have to put it to use. Not really valuable if all the data goes unused that's sitting in our storage. And we use artificial intelligence, machine learning to be able to analyze our data, and many other tools. So data like benefits, where we'd have various sources of our data, like we've covered some things, web interactions, devices, sensors, social media, other more traditional types of database, line of business databases, online transaction processing, other CRM databases, all of that contributing to what is stored in the data lake. Then we can use that to use other tools from AWS to generate a catalog and perform processing on that data that's stored there. One of the main goals of the data lake is to decouple the storage from the actual compute processes. Because we haven't done anything to the data yet. That's kind of the point of the data lake. All the data just goes in its raw format, no pre-processing, and we store it in the data lake. Then after that, we can apply other processes like our machine learning or Athena or something along those lines to then process and analyze the data to extract the meaningful information from it. Now, if you compare that to a data warehouse, also a central repository of information, like coming from possibly multiple data sources, but much more structured than the data lake. So you have a little bit different pattern here of the data that ends up in the data warehouse. We have our data coming from a variety of sources, but before it's stored in the data warehouse, we do some processing: extract, transform, and load. Right? ETL processing means we could extract data from different types of databases, perhaps transform it in some way, get into a format that is necessary for our data warehouse, load it into the data warehouse. So we then have all the data in a structured format, and data warehouse is really designed for structured type data or possibly semi-structured data. Then we can generate reports and other information or data mining, generate reports and analytics as we analyze that data. But a little different from the data lake, which was designed to just store data in its raw format where there's no pre-processing. It's all done after the fact. We put it in storage, then we process it. I'll process it later. So if we compare the two, as I've been describing, the data stored in the data warehouse, structured, processed data from a variety of different types of databases. The data lake, structured, unstructured, raw data, d- doesn't really matter. Anything. That's the point. The data lake. Anything can be just stored in the data lake. And what about the schema? What about the format of the data that's being stored? With the data warehouse, typically a very tightly defined, rigid, and predefined schema. And schema on write, meaning that's the processing we're doing here. Before it gets stored in the data warehouse, it is goes through this ETL process, so it's in a known given format that ends up being stored in the data warehouse. As we're writing it to the data warehouse, it has the schema that is already defined. Whereas the data lake, we're storing all this raw data in the data lake, and there's no really structure or schema until we read it and process it after the fact. So that's part of the decoupling of the storage from the actual processing. No, just dump everything in the data lake. We'll process it later. And at that point, we apply some organization to it, schema on read, when we're reading the data later. Price and performance data warehouses tend to be more expensive because you have that upfront processing, like the ETL process, before we can store it in the data warehouse. But usually provide better performance. You optimize for performance and extracting our analytics from the data. Whereas the data lake really leans heavily towards the storage side, is optimized for storing large amounts of data. Then we have to process it later. That processing, depending on other services we're using to analyze the data, could be slow, could be costly, just depending on what you're trying to do with the data in the data lake and how much data we have to deal with. Data quality, for the data warehouse, high quality data, whereas the data lake, quality is going to vary depending upon the sources that deliver the data. Remember, just putting raw information or raw data to the data lake. We have to analyze it and transform it, later. Try to weed out some bad data, possibly. Users who's working with data warehouses, business analysts, and others who's working with data lake typically would be people in the area of data scientists, data developers, data engineers, business analysts, possibly also, as we're running analytics on our data with things like machine learning, for example. But in the analytics, we end up generating a business intelligence, visualizations, reports from batch processes that we ran on the data warehouse, analytics being performed by machine learning, data discovery, profiling when we're dealing with a data lake. So one architecture that AWS is uh, presenting here, one architecture is we call this a lake house, which is a combination of a data lake and a data warehouse, trying to get the best of both worlds because the data lake and the data warehouse really they excel kind of different things. So this is the goal here is to provide reliability and the structure that's present in the data warehouses, but combine it at the same time with the scalability and agility of a data lake and be able to have just the two sort of blended and merged together. So we get the flexibility, cost efficiency, scalability of data lakes with the data management features like the consistency and transactions being performed that come from a data warehouse. So starts at the core with the data lake, storing all the information, but then we're utilizing other services as we extract information from data lake and analyze it. It could end up in a variety of type of databases, in a data warehouse, a relational database, a non-relational database. So modern data architecture really is connecting these multiple foundational components we see here. We've got a variety of data, a variety of sources of data that end up being going into some storage, like being stored in a data lake. From that, we can then generate, use tools, business intelligence tools to generate results, machine learning to generate analytics and results from the data that's stored there. Move the data in and out of other databases if necessary, all in a scalable, highly performing manner to keep up with the demands of today's organizations. So if you're looking at AWS, like some of those services that we had discussed previously, we can find all these services in the AWS interface itself. Like if we look at SageMaker, for example, SageMaker came up when we were talking about using machine learning. This is a service you can use to build, train, and deploy machine learning models that you could apply to your data in your organization. Then there was Athena performing SQL type queries on the contents of S3, interactive query service to analyze data in S3 and other data sources using standard SQL type queries. We also looked at the Glue service that came up, AWS Glue Data Brew, AWS Lake Formation. We're looking at Glue. Glue is really a ETL type of service. Cataloging data, building, extract, transform, and load jobs, prepare your data for analytics. We could use Glue and apply that to a data lake to generate a catalog of the data there and then perform the ETL ETL transactions on the data. Data lake service here. Lake formation. That's the one I was looking for. Like a lake formation, create manage data lakes, including things centralized access control. So you've got security controlling who has permissions and privileges to the data that's stored here, all built on Amazon S3. That is the underlying storage we're using here. And as we saw on some of our slides describing the overall process, that's what they're recreating here too. We ingest the data, organize it, got security and permissions restricting access to the data, and then we can choose to expose it and use it with a variety of other services, like we would use Glue with lake formation, for example, to generate a catalog and perform the detail actions on it. So if you wish to continue your learning, there's a variety of resources available from AWS. If you find your way to the AWS site, aws.amazon.com, and search for any of those things we were discussing: Glue, lake formation, EMR, SageMaker, etc. You'll find that AWS generates a large amount of documentation and white papers and user guides and developer guides for all of their services. So Redshift came up, our data warehousing service. So a lot of documentation you find on the AWS site. Additional training can be found through a variety of blogs, so additional information. If you find the blog section on AWS, aws.amazon.com, there's blogs relating to a variety of topics here, like the data analytics blog in this example. Also, AWS has a variety of documents referred to as the ramp-up guides. Ramp-up guides is it's a PDF with a list. It's like an index. It's a PDF with a list of a variety of other resources. And the ramp-up guides are built for specific domains like data analytics. So here's a list of resources you could utilize to ramp up and get up to speed regarding data analytics on AWS. It's also the Skill Builder site, if you're not familiar with that. Skill Builder, like this, explore.skillbuilder.aws is the main site. And this is a large number of online digital training. Some of it free, some of it not. There's also a subscription side to Skill Builder. To gain access to all of the content, you have to subscribe to the service. But many things are free. As you see the things that are showing up here listed as free, which means you only need to create an account so you can sign in. You can log into Skill Builder. No cost there, and access all the free courses, even if you don't have a subscription. So you have the free digital training coming from content like Skill Builder, classroom-based training too, so instructor-led courses, official AWS classes. And then there are certification exams if you wanted to pursue certification with AWS. For example, these are some of the certifications. There's one for data analytics. There's a certification for machine learning. There's a certification for working with databases on AWS, as well as a variety of others for developers and architects. There's specifically certification dealing with data analytics in the context of working with AWS and AWS services. That concludes our presentation. Thank you, everyone, for attending. Thank you for taking the time to listen.